Hi, I'm David Bolton of GoParallel, and today I'm going to show you how to get started with NumPy, the numeric library for Python. If you want to do number crunching, then NumPy should be your first port of call. Here's a program to show the performance that NumPy can provide. It uses a sieve of Eratosthenes to get all the primes up to 500 million. There are over 26 million primes, and the program takes just over 3 seconds to find them. The last prime it finds under 500 million is 499,999,993. Let's just see me run it here. And this is running in IPython, which is a shell that lets you time Python programs. It's very useful. We'll come back to this in a minute. And it does several runs and then shows you how long it takes to get. Now I'm using a version here that's set for 50 million, but I can easily change that. Here, this is the program. I'm going to up it to 5 million, save that, and then just run it again. In fact, I'd already upped it, so let's make it down to 50 million and run that. And it should do it in 322 milliseconds per loop. Let's start by assuming that you've got Python installed and working. If you haven't got it, then you need to go to python.org and download it. This is Python here, and this is a download page, and you can see you've got download Python 3.5 or 2.711. And once you've got Python installed, you then need to go to scipy.org and download NumPy. And once you've downloaded it, you then need to install it, and that depends upon your Linux distribution. In my case, I'm running Ubuntu 14.04 LTS, and this is running under VirtualBox in Windows. Just to prove it, there's my Windows screen behind. I'll just put this back. Thank you, Windows. To install NumPy on Linux, you can use this command here, sudo apt-get install python-numpy. Now the actual package there of NumPy depends upon your Linux distribution. For Debian and for Ubuntu it's Python NumPy, but for other distributions like SUSE or Red Hat it's probably, I think it's slightly different. Also, this installs a 2.7 version, but there is a version 3, so you just alter it to 3, install Python 3 NumPy, and that'll do it there. If you're running Python on Windows, then you need to go to this URL, and that's www.continuum.io-downloads. I'll zoom in on this when I edit the video. Then you've got Anaconda for Windows, either 2.7 or 3.5, and there's also a Miniconda which only has a smaller number of packages. The full Anaconda has, I think, over 100 different packages. It's very, very good. As I said, NumPy works with both the 2.7 and 3.5 versions of Python. My favourite's the 3.5 version of Python, but that's just my preference. I also like to install IPython from IPython.org as it simplifies timings and lets you run Python scripts directly. If you look over here, I can see me running IPython, and that gets the command line back, and that's %time it %run eras.py. And that runs the program as we've seen before. Let me walk you through the sieve program. The first line here, import NumPy, is needed just to import the module. That's once it's been installed. The function primes from 3 to n is where all of the donkey work is done here. We call it from down here, but this is where everything is happening. And the first line, sieve here, calls NumPy what ones, and this creates an array which is size n/2. I'll come to that in a second, and it's of type bool, and it's setting it all to 1, which is equivalent of true. Now the reason that it's n/2 is we're not storing the even numbers, so if you've got all the numbers up to, say, 50 million in this case, then we only have 25 million slots. The Python range function takes start and stop values and step. So that's here, it starts at 3, it stops at the square root of n plus 1, and the step is in 2, so it's only ever dealing with odd numbers. If the sieve i/2, again this is because of the only checking the odd numbers, is true, then this clever little statement goes through and uses the value that we're looking at and sets them all to false. So with 3, it will set 3, it won't do 6, so it's not there. So the next one is 9, it skips 12 because it's even, and the next one is 15, and so on and so on. It sets those to false. Next time around this loop, we're with 5. So 5 is true, so we set it to false. 10 isn't is false, so we skip it. 15 is also false because it's been done by 3. So the next 20 we skip. So the next one after that is 25, and then 35, and then so on. And when we do 7, we'll skip 35 because we've just done it. And this clever algorithm is incredibly efficient. It's very optimal, if you like. And as you can see, it can do it can check 500 million numbers. Well, half of that for seeing the rod in just under 3 seconds, which is pretty powerful processing, if you ask me. The final bit of the function, which returns all the prime numbers in a big array, and it's quite a bit of complicated Python here. The non-zero, the NumPy non-zero function collects together the indexes of all the values that are non-zero, and then with this little bit of processing here we get the values and build them into the array, and that's what gets returned when we run this. It's a clever bit of code. It's NumPy's arrays as the main star, giving a massive speed increase to code that uses them instead of Python's lists. This is partly done by insisting that arrays hold the same data type. Also, arrays are a fixed size. They're not like Python lists that can grow dynamically. Much of the NumPy code is also pre-compiled C code, so it's been optimized, and that's why it runs so fast. NumPy provides a comprehensive list of functions that can process a vector element by element. Generally speaking, all operations, not just arithmetic operations, but logical, bitwise, functional, etc., behave in this element by element fashion. The syntax is much simpler, making the code easy to read and understand. NumPy builds on some standard Python concepts such as slicing and extends it. You should be familiar with that, as well as tuples and object-oriented programming in Python before diving into NumPy. But apart from that, it's very easy to use. Conclusion here then is Python continues to grow in popularity, and its ease of use with a much shallower learning curve than, say, Java or C++, coupled with the performance of Compile C, makes a potent combination in the scientific and high performance areas. Thank you for watching this. I'm David Bolton of GoParallel.